Okay, welcome back. Some more math videos. This one today discusses different ways of solving equations, specifically looking at rational, radical, and absolute value equations. Notice I threw in a different picture. That's me in a fun run here a bit ago. We went 3 kilometers and I didn't run a whole lot, but walked a bit. It was fun. Okay, first off, solving equations. We know that an equation is I guess the equality of two expressions. I have something over here, I have an equal sign, something over here. And somewhere in this mess there's going to be an x. And what I need to do is to isolate that x so I get x is equal to something. And we know the basic properties of solving equations would be like the addition or subtraction property. So if I have x plus 4 equals 9, I can subtract 4 on each side. If I have the multiplication division property, so if I have 2x is equal to 8, I can divide both sides by 2. Those are properties that I can use. Today we'll look at some other properties that we'll use to solve rational, radical, and absolute value equations. First off, rational equation. If I see the word rational, I automatically think fraction. And if I need to solve equations that involve fractions, for example, x over 4 plus 9 equals 18. There's an equation. If I need to solve for that value of x, there's one real quick, easy, maybe not real easy, but a fairly straightforward way of solving any equation that has a fraction in it. And indeed, the x could be on the bottom. It could be 4 over x plus whatever. And the rule, I like to call it, you won't see this in a book, but unless I write a book, it's called the I hate fractions rule. And it simply states that you can remove all the fractions of every term in the equation simply by multiplying every term in the equation by the lowest common denominator. Let's see how it works. Here's a question here. A third minus 5/6 equals 1 over x. X is on the bottom. I'm thinking, oh goodness sakes, problem. But let's see how the I hate fractions rule works. First, you find the lowest common denominator. I look 3, 6, lowest between that would be a 6, but here I've got an x. Therefore, my lowest common denominator is going to be 6x. Now I multiply every term, and sometimes you can just do this in your head. I typically like to do it out, but it doesn't matter. So I've got 1/3, there's one term. I've got 5, 6, knows I'm leaving myself a bit of room, is equal to 1 over x. So I'm going to take and I'm going to multiply each term. Here's a term, multiply it by 6x. Here's a term, multiply it by 6x. Last term, multiply it by 6x. Now when you simplify, the 6 goes into 3 twice, so with this first term I'm just going to be left with 2x. Notice no fraction. I don't have to write that denominator on the bottom. I'm multiplying every term by the same number. That's legal to do, and when you do that you lose the fraction. 6's cancel. Here I'm left with 5x. On the other side the x's cancel. I'm left with 6. Bam, I've got an equation, no more fractions. Works every time, works like a charm. Subtract these, so collect like terms, use the division principle, and I get the solution to this equation to be -2. Now, in many rational equations, or radical, or absolute value questions, you have to go back and make sure you check your answer. So I'm going to check it over here just to make sure. A third minus 5/6 is equal to 1 over, we come up with -2. So 1/3 would be the same as 2/3, or 2/6, I mean, minus 5/6, and that supposedly is equal to -1/2. 2/6 minus 5/6 is a -3/6. Yeah, I can see it happening. This is the same as this, checks out. So always go back, especially with these complicated ones, and check. Here's another equation. Oh, goodness sakes, I've got polynomial things on the denominator. That's okay. I can use the I hate fraction rule. If I factor this, I know it's a difference of squares. X minus 2, x plus 2 is equal to x times over x minus 2 minus 2 over x plus 2. Okay, lowest common denominator. Here's two factors. Well, these are contained in there. And so my lowest common denominator is simply x minus 2 times x plus 2. So if I multiply every term by that, and here I'm going to try and do it in my head. You could do it out like we did it here. Like rewrite your equation, multiply each term by the lowest common denominator. In this case, I'm just going to try and do it in my head. So I'm taking this and multiplying this term by it. Oh, both top and bottom will cancel. I'm left with an 8. I'm taking this and multiplying it by this term. The x minus 2's would cancel. I'd just be left with an x plus 2 on the top, plus this x that's there. You want to work through that a little bit. Now I have to multiply this term by x minus 2x plus 2. The x plus 2's would cancel, so I'd be left with the 2 times by the x minus 2. And there I've got an equation, no fractions. Now it's just simply simplify it. So 8 is equal to, this would be x squared plus 2x minus 2x plus 4. Simplifying a bit more, the 2x's would cancel, so I have x squared plus 4. If I take the 4 to the other side, it'll subtract. I'll come up with x squared is equal to 4, and x is equal to a plus or a minus 2. Boy, I feel smart. But one last thing I need to do is always make sure I check. So if I go back, not to this equation, but I have to go back always to the original. If I put a 2 in here, 2 minus 2 is 0. 0 is not allowed on the bottom of the fraction. Therefore 2, a positive 2, won't work. Let's go up and check a minus 2. Same problem right there. The minus 2 won't work either. Therefore, for this question, I would say there's no solution. I felt real smart getting through all that other stuff and solving, and I thought, yes. But when I checked, I found there's no solution. Okay, let's take a look at another principle that I can use to solve radical equations. And that's called the principle of powers. Meaning that if I have a number here, 2 is equal to x, if I want, I can square this as long as I square that. As long as you do, if you do something on one side, as long as you do the same thing on the other side, the equality of the two sides is maintained. And so enter in an equation. Here's an equation here. I've got a radical here. I want to get the x. I'm looking for x is equal to something. So I have to get rid of the radical. Well, a nice way of doing that is squaring it. If I square it, it gets rid of the radical. Because this is a square root, that's why I square it. But if I square this side, I have to do it to that side. So I'm left with 4x plus 1. The square cancels out the square root, is equal to 9. Now I solve. 4x is equal to 8, x is equal to 2. Let's go back and check. Let's check on this side. So I'm going to get the square root of 4 times 2 plus 1. Is that equal to 3? 4 2's are 8, plus 1's 9, square root of 9 is 3. Checks out. I'm okay with that one. Okay, here's another one. Oh, it's a cube root. Oh, that's okay. If I want to solve this one, I would simply cube this side. That would cancel those. Must cube this side. And I'll finish this one. So on the left side, I get 2x plus 1 is equal to negative 5 cubed would be negative 125. Subtract 1 on this side is negative 126. Divide both sides by 2, and I get negative 63. Always check. Plug my answer. Negative 63 right in there. Negative 63 times 2 would be negative 126. Plus 1 would be negative 125. Interestingly enough, I can take the cube root of a negative number. I can't take the square root or the fourth root, but I can take the cube root. And sure enough, it does come out to negative 5. Checks out. I'm correct. I am so smart. Okay. Let's try another one. Here's another radical equation. This one's a bit different, however, because the radical isn't on the side by itself. That's the first thing I have to do. Isolate the radical. Let's write that down as something important. Isolate the radical first. So I move to the other side. That's not too bad. Is equal to x plus 2. Now I need to, since this is a square root, square both sides. Here I'm going to be left with 7x plus 4 is equal to. When I square this side, be careful that you don't just say x squared plus 4. It's x plus 2 all squared, which means x plus 2 times x plus 2. So I have 7x plus 4. If I FOIL, I get x squared plus 4x plus 4, I think. Oh, it's a quadratic. To solve quadratics, we just went through some of those. I bring everything to one side. 4x take away 7x would be a minus 3x. The 4 over there subtract would be 0. So this would be plus 0. If I have a quadratic with only two terms, I can simply factor out an x and then use the 0 property to say x could be equal to 0 or x could be equal to 3. Those are the only two numbers that when plugged in there give me a 0 on the other side. Last but not least, let's go back and check. Let's check a 0 first. I put a 0 in there. 7 times 0 is 0, plus 4 is 4, square root of 4 is 2. Let me think about that. 2 take away 2 is 0, and that's what I wanted to get. That's what I was plugging in for x. So yeah, 0 checks out. Let's check out 3. I put a 3 in there. 7 times 3, so I'm plugging in 3. 7 times 3 is 21, plus 4 is 25. Square root of 25 is 5. 5 take away 2 is 3. That's the number I plugged in. Checks out. I probably should write out the whole check down below, but I just wanted to do it mentally. But it's important to check. Okay, the last type of equations that we're looking at are absolute value equations. Here's one right here. The absolute value of x minus 5 is equal to 3. Now, if I were to take and pretend that this wasn't there, pretend you don't know that that's there, I know that the absolute value symbols basically just cancel out the sign of any number. The proper definition is the distance away from 0, just a distance. But essentially they get rid of the negative sign. So inside here, in order to get an answer of 3, I know that the absolute value of 3 would be 3, but I also know the absolute value of negative 3 would be 3. So whatever's underneath there in this spot here has to be equal to 3, or has to be equal to negative 3. So what I simply do to solve an absolute value equation is let whatever's underneath there, let x minus 5 equal either of those choices. It could be a 3, or x minus 5 could be a negative 3. I have to account for both of those. And then solve the appropriate equation. So for this top one, I would come up with 8, and for the bottom one, x minus 5, if I take that, that's a positive 5. That'd be positive 2. So in this particular equation, x could be 8 or x could be 2. Let's check. 8 take away 5 is 3, absolute value 3, 3, check. Let's check this one. 2 take away 5 is a negative 3, absolute value of a negative 3 is a positive 3, check, worked. Okay, so absolute values, you sort of, you look at this number and say whatever's inside could be a positive or a negative one. So let whatever's inside equal a positive or a negative, and then solve those equations. Let's try another one. Oh no, I don't have the absolute value sign by itself. That's my first thing I need to do. Say I did the same thing with radicals. Isolate the absolute value portion of the equation. So I have to use the addition property to move the 5 over. So I get the absolute value of 2x minus 1 is equal to plus 5 minus 3 is 2. So whatever's inside here whatever's underneath my red there, could be a positive 2 or it could be a negative 2. So let's write those. So 2x minus 1, whatever's underneath there, it could be a positive 2, or 2x minus 1 could be a negative 2. Solving the equation leads me to 2x is equal to 3 and x is equal to 3 halves. Or, move this 1 over there, that would be a negative 1, so 2x is equal to a negative 1. Divide each side by 2, I get negative 1 half. So my two answers then are 3 halves and negative 1 half. Again, I should go and check those. Okay, the last section, or the last part of this section in the textbook, talks about manipulating formulas and using similar rules that we have looked at. Here's just one example. Here is a rational equation because I have fractions, and I want to solve for p. I look there and I see p on the bottom. I can't just flip things over and say p is equal to q plus r. That's breaking rules of Bedmas, because I have to get these things together before I do any inverting. So I can't simply do that. But I have seen how to solve rational equations is use the I hate fractions rule. Multiply every term by a lowest common denominator. When I look at the denominators here, they're all distinct, and so the lowest common denominator will be p, q, and r. So multiply every term by those. So first one, if I multiply by PQR, the p's will cancel. I'm left with QR. Next one, when I multiply by PQR, the q's cancel. I'm left with PR. When I multiply by here, I'm left with PQ. I said P, I wrote an R. I meant to go PQ. There. Now I have no more fractions, so I can solve for p. I notice there's two p's here. My way of doing that is to factor it. So I'll have a p, factor out a p, I'm left with r plus q is equal to qr on this side. Now divide both sides by r plus q, and I have solved for p. r plus q, and I'm done. So today we just looked at 3 different ways or different types of equations. Rational ones, those are ones with fractions. We learned to use the I hate fractions rule. Multiply every term by lowest common denominator. Get rid of fractions, solve what's left over. We also looked at radical and absolute value equations. Both you need to isolate the radical or the absolute value first and then solve the equation as we've shown. Okay, good luck with those. Talk to you again.